Okay, this is Dynamics Quiz 6, and let me get my pen here. What we are going to have is we have a roller, and this roller is suspended by some cables. Oh man, there we go. Some cables. This is TA. This is TB. Yay, it's coming back. Okay. TA, tension A, and tension at B. That rope wraps around. And here we're going to have the wonderful NG. And here we are going to have our moment of inertia, because we will have a mass times acceleration. Okay, we are given some things. We are given the mass, and that is equal to 1037.2 kilograms. We are giving the radius of gyration, and that is 130.1 millimeters. We are given tension at A, which is 3126.2 newtons. We are given the tension at B, which is 3365.7 newtons. And what we're asked to find is the angular acceleration, given all that. Well, we know that the radius of gyration is another way of expressing the moment of inertia at a distance from a centroid. So we can, the relationship for that is moment of inertia is equal to mass times k squared. K squared is your radius of gyration. So we can definitely solve for that by going 1037.2 kilograms. We place in our radius of gyration, we'll go 0.130. And that will give us 17.55. Let's cut it right there. That's a good spot to truncate it. 17.556 kilograms meters squared. Yeah. Okay. So now that again gives us the moment of inertia. So now that we know that, we can solve for the moment of inertia by essentially adding up the sum of the moments at G, G being representative of the center. Oh, another thing I didn't give, that's 100 millimeters. G being the center of the body. So what we're going to have, if we are looking at the body, let's make that a little bit bigger. We are going to have, tension at A, tension at B, and we are going to have this guy here, and we have MG here, and we have MA in the other direction, whatever it may be. Okay. But we do have two ropes, not just one looped around, so what we'll do is we can sum all that up, we know that the tension at B is larger than the tension at A. And if we look here, just analytically, we can see that the tension at B, since it will be larger, will be causing a positive moment. And the tension at A will be causing a negative moment. But since this is larger, you'll have an overall positive moment. What we can actually do is we can just go 2, because we have 2 ropes, TB minus TA times the radius, which in this case, if it's 100 millimeters up there, this section right here, then we will have 0.05 meters here. And that is going to be equal to the moment of inertia times the angular acceleration. So we are going to have 2 times the tension at B minus 3126.2 times 0.05 is equal to angular acceleration, and we'll just do this here. Don't fail me now, algebra. Don't fail me now. Okay, so I like to do all my calculations very stepwise on my calculator because I don't trust myself with parentheses and order of operations. So this might take a minute. Okay, so angular acceleration is equal to 1.3642 rads per second squared, which is pretty much 1 point, not a time, 1.36 radians per second squared. And that is it. That's the angular acceleration.